Hello. Okay, hello guys, hello. Let's check the network very quickly so that we can jump right into the lesson. Is the network okay? Is it lagging? Am I audible? Are we able to see, hear, and feel? Evening to everyone. Evening. You guys are so generous with your evenings. Evening to everyone who is evening me. I'm evening you back. So hopefully we are actually we are able to hear each other. Audibility is clear. You are hearing me. You are seeing the white paper in front of you. There is no lagging. The network is fine. Can we confirm all of that for the grade 11s? Is everything fine? Networking, visibility visible, audibility audible. Can we confirm just that quickly? Okay, network, Liam is saying network. So network for you is not good, or network is just not good. Network is just not good now. How is it now? Is not good, is not good. Yeah, it's not good. Yeah, it's not good. Yeah, it's not good. How is it now? Audibility. Okay, I just need to confirm in the large majority. Boitumelo says it's better. Chireleto says it's better. It's vivid now. Sban is saying. Okay, then Puti, I think if it's still not good for you, then yeah, I think it might just be from your side then, because for me now it's saying good connection. It says good connection. For me, it's very good. It's saying for me, so I no longer have the problem. So the problem must be with the other entities. So for you guys then, please fix what you need to fix your side, and yeah, let's hope for better days, right? All right, let's get this party started, guys. Yesterday we did solving for x by completing the square method. Solving for x by completing the square. So basically what I want to do is I want to just do one last example so that I can, well, let me do one of the problems that you had to do for homework. One. I'm not going to do all, just one. Just to sort of recap on the concept and so make sure that we are all good. So let's just do this one. It says solve for x by completing the square. And let's say that this question says that we need to solve for x by completing the square, and we need to leave our answer in simplest set form. Do we all understand when I say leave your answer in simplest set form, what we mean by that? Can we all confirm that we know what it means when we say leave your answer in simplest set form? Can we confirm that we know what that means? Yes, Liam. It means in our answer, in our roots, in our answer there has to be a root. In other words, we have to have an irrational number at the end. It needs to be left in the irrational state. So that's very important. There needs to be the square root there. Okay, I am happy. So let's just look at this. Just one example, guys, and then I'll move on to what I have geared up for you today. So the question is 2x squared minus 5x is equal to 10. We are supposed to solve for x by completing the square. So do you remember the first step? We said that if the equation, let's say it was in standard form, 2x squared minus 5x minus 10 is equal to 0, we first transpose the constant term. Here, the constant term is already transposed. Then 2. Boitumelo have said it. We have to then divide by the coefficient of x squared. So let's do that. But we do that for all what? For all the terms in the equation. Thank you very much, Boitumelo. Okay. Then the next step, we then get x squared minus 5x over 2 is equal to 5. Now we are ready to do the next thing, which is what exactly? Okay, I think the comment section will help me out. You guys are the ones who will help me out. The next step that we then have to now cater for with this equation. Thank you very much, Precious. Then what we do is we are going to, after the x term, add half the product of the what? Half the product of the coefficient. In other words, half the product of negative 5 over 2. And then we are going to do what? Square it. Okay? Yeah. Okay, Tina, we confirmed the network. It seemed to suggest that we are good. So is it you or is it the network? Is it you or is it me? Maybe others can confirm. Maybe things have changed with me. But for me, it still says good connection. Then Tina, it's you. So we need to fix things your side. So we add half the product of negative 5 over 2 even for the right hand side. So we do that. We add half the product of the coefficient squared. But we do that as well on the right side. We do that on the left and on the right for both sides. Okay? That's step number 3. We are done. Next, now we have to sort out what is in the bracket. 1 times negative 5 is negative 5 in the numerator, and 2 times 2 in the denominator is 4. So we have x squared minus 5x over 2 plus negative 5 over 4 squared. We equal that to 5 plus. We sort out what is in the bracket here. We also get negative 5 over 4, the whole thing squared. Then remember, what did we say will form here on the right side of the equation? We have what we have formed here, a perfect square trinomial. What do we do, guys, with that perfect square trinomial? We factorize it. Do you guys remember how we factorize it? Obviously, there's a square bracket there. We know that we are going to write our x here, and then we are going to write, so our x, which is basically the x below the square here, and then obviously the negative 5 over 4, which is in the bracket, will follow there. Okay, remember, greatest op, it's not plus 5 over 4, it's negative 5 over 4. What do we have inside this bracket? We have negative 5 over 4. So that is what features as the second term in the brackets. Okay, please, guys. Okay, we don't want to be messing up with the signs here because it's very clear. The x, the negative 5 over 4. We're just leaving the squares behind and we are taking the bases of each square. The x, then the negative 5 over 4. Then we square that bracket. That's all. Okay. On the right side, we have 5 plus. Now, bad math says we take care of the bracket with the square. If we apply the square to the negative 5, we've got 25. If we apply the square to the 4, we've got 16. Okay, and all we have to do then basically is to add these fractions so that we can get the actual number there. So what's 5 plus? I just simply take my calculator. I don't even want to waste time. 5 plus 25 over 16. That gives me a 105 over 16. So I just go ahead and write that on my right hand side of the equation. Then on the left I have x minus 5 over 4, the whole thing squared. What is the next step that we take? We take the square root on both sides. We take the square root here and we know what it will do. We take the square root on the left with the fraction and we include plus minus. That is to accommodate the two solutions of x that we are going to get. Then the square root and the square, they have a cancellation effect on each other. So I left with x minus 5 over 4 alone on the left. And then when we apply the square root here, at the top, plus minus 105 stays. The square root of 16 in the denominator leaves us with a nice 4. Then we transpose. We get x minus 5 over 4 is equal to plus 105 the square root of 4, or x minus 5 over 4 is equal to negative the square root of 105 over 4. These are two independent solutions, and then we solve them independently. Okay. Where does the 4 come from? The square root of 1 over 5 over 16 was what we had. When we split the square root for the numerator and the denominator, the square root of 105 is retained. The square root is retained for 105 because 105 is not a perfect square. But the square root of 16 is equal to 4, which means the square root is removed in the denominator. That's why the square root now is only for the 105. Okay, I hope that makes sense now. So that's where the 4 comes from. Then we can solve these independently. Remember, the question said we need to actually get this solution. Thank you, boss lady, for the ice cream. It says that we need to write our answer in what? We said we're going to write our answer in simplified set form. So we transpose the negative 5 over 4, we get positive 5 over 4 on the other side, plus square root of 105 over 4. Or x is equal to, we transpose the minus 5 over 4, we get 5 over 4 minus the square root of 105 over 4. So these are the two x solutions. Then we just go to our calculator to go and verify and check, is the simplified set form, is this as simplified as we ought to have the solution be? So let's go and just punch in our calculator. What's 5 over 4 plus square root of 105 over 4? So we say, go ahead, 5. Okay, let's write our fraction. We say 5 over 4 plus the square root of, okay, let's just write the fraction, the square root of 105 over 4. We press equal. So the calculator still gives us this set form as our answer because the question said leave your answer in set form. So we do not press SD and leave it in decimal places. We simply write the answer as it appears in our calculator. Okay? Yeah. Then the other answer, the other solution, 5 over 4 minus. So let's go and change in that fraction. We use our back button. Go and change the plus this time to what? To minus, and see. Okay, so even for the other side, we get x is equal to 5 minus the square root of 105 over 4. So that's done. That's done and dusted, guys. That is basically just a recap of what we did yesterday. Just to sort of like say, when we were asked to solve for x by completing the square, these are the steps that we take, okay, when we are solving for x by completing the square. This is grade 11, okay, this is grade 11. Those who are probably running into my channel for the first time and they're like, hi Bo, and then what's happening here? Yes guys, we are pushing Maths live lessons on this beautiful channel called Maths is a Game. We're running these channels up until the 12th of beautiful January. We've been in it, we've been doing it, we've been busy. In December, whilst you guys were enjoying and having fun, those who are joining, I were busy with maths, we're pushing, you know. Those who were with me in the beginning will know we were pushing like nobody's business. Now we are in this topic, all right, and we are continuing to a new topic after this example. So I just did this example for those who were actually here yesterday, just to remind or to recap what we were doing, because we were doing solving for x by completing the square. So very quickly, I'm just going to remove the comment section so that the people can actually see the entire sort of like working out, so that those who want to screenshot can screenshot. Then I'm going to actually move on to the next thing that I want to take care of in our quadratic equation journey. All right. All right. So hopefully all people that wanted to take a screenshot have taken it. Now I'm going to return the comment section. I'm going to return the comment section. I'm going to allow you back. Okay, comment section is back. All right, so now we're moving forward, we're moving on, because that was just for us to sort of like recap on what we did yesterday. So today now we are going to move on. So far, guys, remember when we started quadratic equations in this grade 11 syllabus, we said that there are three kinds of ways to solve for x. There are three kinds of ways to solve for x. Okay. Precious is asking, say, are you going to do functions as part of equations? No, guys. Functions are not part of algebraic equations and inequalities. Functions are an independent topic. Okay. But we use the concepts and the principles of quadratic equations. We use them when we are solving certain aspects of functions. Okay. And you guys are also asking here, are you gonna continue teaching us even if schools open? No, that job will be done by your teachers. Yeah. All right. Yeah. Yes. Okay. So like I said, I'm not going to teach functions, all right, now. Functions will be done later, right? But we need this foundational knowledge of equations to be able to solve things that are related in functions, okay? So that's coming up. And for a grade 11 learner, because I'm teaching grade 11s now, don't worry, that time will come. You'll be able to do that thing. Okay, so going back to what I was looking at, all right, yeah, I said to you there are three ways that we can solve a quadratic equation. We looked at the first way. Do we still remember what the first way of solving a quadratic equation is? What method can we use? What is the first method we started doing at the beginning? What was the first method? What is the first method? Okay, we'll discuss this whole thing of teaching after the holiday. I mean, after the 12th. Please just concentrate now. We need to concentrate on the topic. Don't let something that is, that is yet to happen or that might or might not happen affect you now. Let's focus here. So the first method was factorization. We looked at that, guys. And we saw that this factorization method, we used it in grade 9. We used it in grade 10. Now in grade 11, again, it's still there. So we need to be able to factorize. Guys, factorization is a big thing. You guys need to make sure that factorization, you are a master of factorization. You need to become masters, all of you, of factorizing. All right? Then we looked at a second method. What was the second method of solving for x? Second method of solving for x that we looked at was, thank you, Claudio. We looked at solving for x by completing the square. We looked at solving for x by completing the square. That is the second method. That is what we covered yesterday. Yesterday, we covered the method of solving for x by completing the square. All right? Now, today, I want to look at the third method of solving for x. But before I go into the third method of solving for x, I want you to first observe what I am about to do. I want someone to tell me, what do we call this? What is this? What is this? Ax squared plus bx plus c is equal to 0. What do we call this? Okay, Sbanimnikati says it's the SF. Gift says it's the quadratic equation. Tlotlo says it's the standard form with a question mark. Sbuda says quadratic equation. Pretty says quadratic. I don't know what quadratic is. Simple form. Adam J says the simple form. She's right. He says it's the standard form. People, this is what we refer to as the standard form of a quadratic equation. Very important. Okay, this is the standard form of a quadratic equation. Okay, I hear you pretty well. All right, so we are on the same page. The standard form of a quadratic equation. Now, let's take it one step further. Let us do the following. Let us solve this standard form of the quadratic equation by completing the square. Let us do that. Can we do that? Can we just solve this quadratic equation, this standard form, by solving for x by completing the square? Let's do that. Okay. Now please observe the following. The first step that we know we ought to do whenever we are solving for x by completing the square is we need to transpose the constant term. Grade 11. We transpose the constant term. So we have ax squared plus bx is equal to negative c. Okay? All right. I hope we are together so far. All right? Next step after that, we divide by the coefficient of x squared. Okay? I don't know where you are taking that from. You see, now you are doing funny things. What did I just say? We are going to take this standard form and solve for x by completing the square. Okay? We are going to solve this standard form. Solve for x by completing this standard form equation by completing its square. So what is the method that we follow whenever we are solving for x by completing the square? We always transpose the constant term. So there it is. C became negative c on the right hand side. Next step, we divide by the coefficient of the first term. Okay? Okay? I hope you understand. We divide by the coefficient of x squared. In this case, the coefficient of x squared is what? Is a. So we divide by a throughout. Then we are left with what? X squared plus bx over a is equal to negative c over a. Hopefully so far we are together. We are together. What is the next step after that? We add half the coefficient of the middle term. What's the coefficient of x? It is b over a. So we half b over a, the whole thing squared, but we do that on both sides. We add half the coefficient of x, which is b over a. Okay? We are seeing this, guys. It's coming. All right, let's go. X squared plus bx over a is equal to, we sort out what is in the bracket. Sorry, that's not equal. We write plus 1 times b is b. 2 times a is 2a. Equal to negative c over a. We sort out what's in the bracket. 1 times b, b. 2 times a, 2a. We square it. So far, so good. We are good? Guys, I really hope we are good. Now, these three terms form a perfect square trinomial. So what do we simply do? We just open the bracket. We square it. We know what belongs in the first term of the bracket, x. We just take this x without it squared. What belongs in the second term of the bracket? We just take this b over 2a. It is positive, so we say plus b over 2a. We are together, Mosne? I hope we are. I hope we are. Go to the left. We have minus c over a. Okay? We have minus c over a plus b over 2a, but it's squared. Check this out. We know that addition is commutative. So let's just swap these two around, okay? Does not change anything. If we say b, we apply the squared. What's b? If we apply the squared to the numerator, it becomes b squared. If we apply the squared to the denominator, it becomes 4a. What follows after that? We follow it with minus c over a. Please take note, guys, of what I've just done. This has not changed anything. You remember the b over 2a was positive. It's still positive. It's just that I'm starting with the b squared over 4a. Wow. Thank you so much, LLNS, for the hat and the mustache. Thank you so very much. I appreciate it. Sorry, guys, that was a disturbance, but it was a welcome one. Thank you so much. b over 2a, if I square the b, it becomes b squared. If I square the 2a in the numerator, remember the square is applied to the 2 and it is applied to the a. The denominator on the right, is it not supposed to be 4a squared? Very good. I like this. It is supposed to be Ndando. You are the man. You are the man. Okay. You are the man. Thank you so much for that. So if you apply the square to the b, it becomes b squared. If we apply the square to the 2a, remember the squared is applied to the number and to the letter. To the number, it becomes 4. To the letter, it becomes a squared. Thank you so much, Ndando. You are the man. Okay. Then there's this minus c over a. There it is. Okay. Now, people, please listen to me. Here, okay, we have what? Just before we get into taking the square root on both sides, I want us to note something here very quickly. This is an addition of fractions. When we are adding fractions, right, we usually look for something called the LCD. Now, between 4a squared and a, what is the LCD? When we identify the LCD, people, please take note. We look at the number first, the coefficient, 4, and the a here has a coefficient of 1. So between 4 and 1, what is the lowest common multiple between 4 and 1? Lowest common multiple, which will basically make up the numerical value of the LCD. Yes, thank you, Moitumel. The LCD for the number 4 and 1, the LCD between 4 and 1 is 4. Okay, please, people. Between 4 and 1, the LCD is 4. How do you know that? What are the multiples of 1? When you count in ones, 1, 2, 3, 4, 5. When you count in fours, 4. What is the lowest number that is common? That is a multiple for both 1 and 4. It is 4. So the LCD between 4 and 1 is 4. Please, Claire, please do not understand that. LCD, LCM is a concept you learned in grade 8, in grade 9, in grade 7 it was done. So by now in grade 11, you should be masters in knowing what the LCM is. Then let's move on. For the variable a squared and a, what is the LCM between a squared and a? Do we know? The LCM between a squared and a? We go for the variable that has the highest exponent. We go for the variable. If it's a common variable, guys, if a and a are common bases, we go for the common variable that has the highest exponent. That is our LCD. So the LCD in actual fact is 4a squared. Did you guys listen to me when I said, how do we identify the LCD? Guys, if you don't know how to identify the LCD, there's other sections of the grade 11 work that will actually get in your way. So these are basic things that you should know by now. All right? The concept, you need to grasp it very well. Now, that LCD, remember, When you are adding and subtracting fractions, you cannot add or subtract them until you have the same denominator. So our LCD gives us an idea as to how should our denominators be for both these fractions. Already 4a squared is the denominator for this first fraction, but a does not have 4a squared. So obviously, what do we do to 4a squared to get this 4a squared? We times the numerator and the denominator by 1. So 1 over 1. What would we do to this a to get 4a squared? It means we'd multiply this denominator by 4a. But what we do at the bottom, we must do where? At the top. Now what do we have? We have b squared here minus, what's 4ac times 4a times c? Negative c. It's negative 4ac. Then in the denominator, we have 4a squared and 4a squared. Now we can subtract the numerator because the denominators are the same. They are fashioned after the LCD. Okay. Yes, guys. We are making the denominators the same by using the LCD. Remember, there's a law and a rule about fractions. You cannot add fractions until the denominators are the same. Once the denominators are the same, that gives you the allowance to add the numerators, but the denominator will be kept the same. So what you eventually have on this right hand side is b squared minus 4ac over 4a squared. Do we understand that? Do we all understand how I got here? Yeah, I'm just gonna keep it there for a moment so that people can take it in. Please, people, LCD, yo. At this stage, grade 11s, there are things that people, as people who are in grade 11, we should be so good at doing at this stage. All right. I left the poor right hand side, the left hand side. Okay, that's squared. Now I am ready to actually divide both sides by to take the square root on both sides. So I take now the square root, and I'll take the square root this side as well. But what will I do here? I'm going to say plus minus on the right. Do we remember that, guys? Do we remember that thing of taking plus minus with the square root on the right hand side? Take the square root on the left. What happens? The square disappears. I have x plus b over 2a. Are we seeing this, guys? Are we seeing it? Are we seeing it? Are we seeing what I'm seeing? It's like it's coming together. Equal. Now we apply the square root. Thank you, Zina. We apply the square root on the numerator. When you apply the square root on the numerator, the square root is not going anywhere. When we apply the square root in the numerator, in fact, that plus minus is still intact. But what happens if we apply the square root in the denominator alone? What happens? What's the square root of 4? Anyone know what's the square root of 4? Okay, let's just go back. Mbambi, the square root has plus minus only on the right side of our equation, Mbambi, not on the other side, just on the right side, because we understand that since this is a quadratic equation, it should give us 2 solutions, not 1. So because we want to have 2 solutions, taking off the square root for an equation means that we put a plus minus so that we can accommodate the 2 solutions we intend to get at the end. All right? But back to my question, hopefully you are answered. 4a squared, we apply the square root, it is 2. Apply the square root to a squared, we get a. Because the square root of a squared is a. Okay. So finally, what do we have here? Look at this, guys. We transpose the positive b over 2a, it becomes negative b over 2a on the right hand side, separated by the plus minus, then a square root of b squared minus 4ac over 2a. Hey, chini madoda. Thank you, Zina, for the rosa. Then, do you see what we now have? We have two fractions. They have the same denominator. So that means we don't have to even find the LCD because the LCD is already there. We have 2a. So that allows us to do what? So I'm going to conclude and say x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. Hey bana, what do we call this guy here? Yes, we call this guy something called the quadratic. And it makes sense that it's called the quadratic. How did we find this formula, or how did it come about? It came about through us solving for x using the what? The standard form of the quadratic equation. When we were solving for x by completing the square, we were able to arrive to this beautiful solution. We refer to this as a formula called the quadratic formula. Man, this is so amazing. This then presents the third method that we use to solve for x. We can use this formula. What? We can use this formula that we refer to as the quadratic formula. To do what? To solve for x. We can use this formula. Okay? So, guys, this is it. I'm just going to remove the comment section again so that you guys can screenshot if you want this part where I solved for x by completing the square, this quadratic formula, this quadratic equation. How I was able to get this phenomenal quadratic formula at the end. Okay? This is obviously step by step what I did to get there, and in textbooks you'll find this. It's there, even shortened sometimes, But what I've done is I've actually shown you the steps so that you can even understand where certain things come from. And then ultimately, there's the formula. You see it. Let me just tilt it a bit. Maybe you see now I have to kind of do angles here. But this is the formula. Okay? This quadratic formula is a formula that we can use. It is the third way to solve for x when we are given a quadratic what? Equation. The third way. Okay? And simply put, good people, in grade 11, that's where you first get introduced to this formula. Okay? In grade 11. So I'm going to look very quickly now. Now we have a formula, guys. Hey, look at this guy. Look at this formula. It's so beautiful, this formula. It's lovely. It's lovely. You remember when we were doing certain problems and certain grade 11 students came into the live session and they would say, whilst we were busy trying to factorize, they would be like, sir, why don't we just use the quadratic formula? It's so simpler to use it. And I'd be like, no, guys, please get away from the live. I don't want to hear what you are saying because now we are busy trying to solve for x by factorizing. Now you are making a noise about this quadratic formula. And I would chase them away from the live and I'd be like, please go away because we are busy here factorizing. We want to focus on factorization. We've done factorization, we moved away. Then we did yesterday solving for x by what? By completing the square. We saw what it means to solve for x by completing the square. We did it, we feel it, we know it, we are good in it. Now I am introducing you to the what? To the third method. This third method, it's by using this formula that we refer to as the quadratic formula. It comes from somewhere. It's not something that we thumb sucked. You saw, I showed you where it comes from. It comes from completing the square of a general standard form quadratic equation. Ax squared plus bx plus c. That's where it comes from. That's why we have this thing. Now listen to me, and listen to me very well. When do we use this formula? In grade 11, after learning about this formula, the formula is used. Okay? The formula is used when you cannot what? Factorize. All right? When you cannot factorize. Okay? Are you hearing me what I'm saying? This formula is used when you cannot factorize. It's not just a formula you use every time you see a situation. You're like, I'm just going to use this formula. No, guys, that's not what the formula is designed for. Okay? Yeah? So I hope you understand that. Okay? Yeah. It's used when you cannot factorize. When you cannot factorize, then you must use the formula. So let's look at some examples so that you guys can fully appreciate. And I'm going to give you steps as to how do we utilize this formula. So let's go. Let's say we were given a question. It says solve for x. And listen, here is the 2x squared plus 5x minus 1 is equal to 0. Let's say we were given this. Do you guys see it? Do you see it? 2x squared plus 5x minus 1 is equal to 0. So, step number 1, I'm going to write the steps here. Step number 1, we need to what? Make sure that our equation is firstly in what? In standard form. And you know what I'm going to say? Preferably where a is positive. Make equation to be in what? Make equation in standard form, and preferably a must be positive. That's very important. Okay, I encourage, make sure a is in positive, is positive. Okay, 2. Find the value of A, B, C. And the value of A, B, C simply comes from, when you have the standard form, guys, A is the coefficient of the x squared term. So A comes from the x squared term. B comes from the x term. C is the constant term. I hope that makes sense. So when your equation is in standard form, the number before the x squared term is A. The number before the x term is your B. The constant term is your C. So we need to find those values and write them down. 3. Substitute. 3. Write down the quadratic formula. I'm going to use QF for short. Write down the quadratic formula. You guys are usually given a formula sheet, and the formula sheet will have the formula. But I'm thinking most of the time in term 1, when you write your first control test, your teachers tend to not give you a formula sheet. They expect you to know the formula off by beautiful heart. This is grade 11, those who are joining in. Okay, I repeat, Your teachers tend to want you to know and learn the formula. So this is one of the formulas that should go up on your wall of fame. I said take down Chris Brown and take down Rihanna, take down Beyonce, take down Umlindo, and take down the other lyrics of all the songs that you know and begin to post up all of the content that you will need for this year, so that you will remember and recall it. Number 4, we substitute A, B, and C in the formula. And then 5, if the question says round off to a certain decimal place, that means our answer needs to be left. The roots must be rounded off as such. Or if they say simplified third form, then of course our roots need to be left with a square root, but in the simplified third form state. So these are the steps that are necessary as we solve for x using the quadratic formula. So I repeat, we need to first make the equation to be in standard form, preferably where a is positive. 2, we need to find the value of a, b, and c, remembering that the a value is the coefficient of the x squared term, b is the coefficient of the x term, c is the constant term. Number 3, write down the quadratic formula. Write it down, write down this formula. And then in the next step, substitute the values of A, B, and C into the formula. And I'm going to say using brackets. Please guys, when you substitute something in a formula, you must substitute them. Substitute those things using brackets. And then 4, you make sure if the question had said round off your answer to